How many of you guys are familiar with GPUs? We've got a couple of hands. Some old gamers from the gaming world. So I think Wes touched on this a little bit, but GPUs have lots of cores on them. So we work off of the premise that compute is kind of infinite. So Kinetica is a GPU accelerated in-memory database. You guys are familiar with databases, familiar with in-memory databases, keeping lots of data in memory so that you can access that very quickly for applications. As Wes mentioned, our solution was built in the military. So the military had a problem where they needed to have access to data very quick so that their data analysts could run queries very quickly on lots of different data sources, get information back, and pick a person, point, or place where they think there might be a problem or a potential problem. So hundreds of data streams coming in, process that data very quickly, organize it, and then visualize it. The problem was using traditional databases, it was taking hours for this information to be surfaced up, and which was too late. It wasn't making the SLA. They were looking at other solutions within the open source and the proprietary solutions, and just figured that the CPU is actually the bottleneck. So our CEO and CTO had this idea of building a database from the ground up, utilizing GPUs and CPUs and physical RAM. So this is what's so interesting about working with IBM and the Power Series and the Minsky box is that you've got up to 1 terabyte of RAM. You've got 4 GPUs, you've got CPUs, and you've got NVLink. What we found is the bottleneck became the PCI bus and the ability to move data quickly. And so that actually, or this technology actually enhances the performance of our solution. So we're seeing 1,000x performance increases over traditional databases. We're seeing 100x performance increases over some of the NoSQL data stores and open source solutions that you see out there. We're not everything, but for specific problems, we do very well, right? That could be time series data, it could be geospatial data, it could be as simple as just faster queries. So people who are using some of the BI and visualization solutions like Tableau may have queries, or business users that are complaining about the speed and performance. We have ODBC and JDBC, so we can actually speed up those queries. So if you think about our architecture and where we kind of fit in, where you have ingestion of data, so you might be using traditional technologies, message queues, or maybe some of the open source technologies like Spark or Storm or Apache NiFi or Kafka. The organization of that, we look like a traditional database. I'll show you what that looks like. We have ODBC and JDBC, so you can connect to your legacy systems. We also have connectors for Spark and Hadoop, so that you can hydrate the data from Hadoop up into Kinetica, have fast access to that data, and then flush that with a time to live. And then visualization. We use visualization technologies that could be things like Tableau or MicroStrategies or other solutions you might have within your organization. We've also replicated APIs for Kibana, which is Elasticsearch's open source visualization solution, or Kibana, or you could use something like Node.js to build your own solution. We have open APIs for Java, C++, Python, RESTful APIs. So there's some really cool stuff that we're doing with that. It gives the feel of an open solution, but it is a proprietary database. So if you're thinking about a streaming architecture that you might implement in your organization, something like for IoT, where you have maybe a traditional message broker, or maybe Kafka or Kinesis if you're running in the cloud. Could be Spark or TIBCO or some of these solutions, could be IBM Streams, for example. Kinetica becomes the fast access data layer for fast SQL or fast get, put, and scans. And then you have your visualization solution on the back end. And just to give you kind of an idea of what the technology would look like, we've covered kind of the open source integration points, the other integration points, as well as the visualization and ODBC. But as a solution, this is scale up and then scale out, right? So we want to get big box or commodity server environments, but big boxes with lots of memory on them. And so you use a Minsky box with a terabyte of RAM, and then you look at your particular problem that you're trying to solve. That could be hundreds of gigs to terabytes, to tens of terabytes, to hundreds of terabytes. We're not really a petabyte type solution. You're going to use some kind of a long-term data storage and batch processing solution there. But for your fast access to data, and you're talking about sub-second type queries, this is the type of solution that you want to be implementing. So with that, let's get out of here. And I'm going to show you a quick demo of the solution. So, make sure this looks good up here. Everybody see that all right? So what I've got here is our kind of the back end to our database, right? And what you're going to see is we've got a lot of data in here. I'm going to go into the Twitter data. And you can see as the data is put and organized into the database, it's rows and columns, right? It looks like you would see something in a traditional solution. So you don't have to learn a new data paradigm to implement this type of technology in your organization. A typical DBA or somebody who's a data analytics professional, data professional can pick this up fairly quickly. The thing that I would point out is that one of the things we do is geospatial very well. So you can see like the XY. When you get to properties, you can see the properties, you have data that's held in memory. Store only means we're storing to disk. So everything in our solution is persisted to disk, but it can be stored in disk to save memory space. Some things don't need to be accessed immediately, right? And we also have full text search capabilities built in. So with that, what I'm going to do is I'm going to flip over here. This is a demo that's available online, and I have a bunch of different data sets in here. I've got FAA data, I've got some shipping data, traffic data, and the all favorite Twitter data. What you can see here is we can see how many records are in here. So there's about 4 billion records in this particular thing. You can scale in or scale out. This is actually just kind of a lightweight JavaScript app that we built for visualization of the solution. It's available with the technology, but it's not generally what our customers use. It's something that we've just built to kind of showcase the solution. Now, if you go in, you can kind of change like base maps and stuff like that. So we've got all sorts of mapping capabilities built in. You could go in and let's see, I want to do just kind of show you the speed, and what we're doing is we've got a couple of servers. I think there's 8 servers sitting back in Virginia with K40 NVIDIA cards, and basically what I'm going to do is I'm just going to do a freehand polygon right here, and we're going to go through and we're going to basically go through that 4 billion records. And we've cut that down to 307 million in what, about a second? 2, pretty quick, right? For points on a map. And these are real live tweets. I can actually turn on the live tweet here, and you can start seeing. So this is built for like streaming, but you can go and you can start just flipping through tweets. And I apologize, these are not censored at all. So
that's how you know it's real.
If you see IBM is awesome. Somebody actually tweeted that. But you can also go down here and you can do like time series type data, and you can basically shrink that again. So now I've got this down to 145 million. So there's some pretty interesting stuff that you can do here. You can also go in and like we can look at air traffic control data. So this is air traffic data, and we may want to go in and do, I don't know, let's say 35,676. We're going to do all flights we're going to do flights over that from an altitude perspective. So we went from 310 to 100 million in a pretty quick amount of time. Again, you can go in and do, your time series and go down here. We could go up and draw a filter around this. So you may want to go and do a rectangle, and we'll do this across. And now you can see we've gotten down to about 5 million records from 310 million in a pretty quick amount of time. One of the things that we've had fun with the Twitter data, and I'll talk a little bit about, there's a large retailer that Wes had mentioned and some of the things that they're doing with this. So they've actually building out a fairly large cluster utilizing the Minsky boxes and our technology. And the idea for them is to tackle a number of different use cases, one of those being real-time inventory management. So the ability to look at inventory in real time at a store level, and to do that globally, and now to be able to see from a category perspective maybe how things are selling. So we could overlay this with weather data, for instance, and now they can see if a weather pattern is pushing across the Northwest, and maybe they see that coat sales have gone up by 45% in Chicago, and they can see that that's going to move across down to St. Louis, and then maybe it makes it all the way down here to Georgia. I don't know if it's ever going to get cold here again. But if it did, then they can start to adjust inventory and make sure that they have enough coats of that particular style, right? Not just category, but style down to that type of level. Maybe it's even to color, to say that we need to order this many more coats because we can project that the inventory levels are going to need to change that much. Or maybe in their grocery area where they have milk, but it's not just milk as a category, right? We have 1%, 2%, we have fat-free, but we now have these categories like organics, right? So maybe the organics sell much better in Roswell than they do in Alpharetta, or maybe it's vice versa, I don't know. They can start to move inventory around in real time, and they can do geofencing. So one of the things that they were looking at doing is, we'll just zoom in here, and they may want to geofence around a specific area, but they may also want to look and do like a full text search. So we're going to do today tire and rain within 5 words. Hopefully I typed that out correctly. It's really small here. But you can see we went from 3.8 billion down to 375 tweets. And we've got tire and rain within 5 words. And so we don't have the full Twitter pipe going, and we only pick up the ones with geolocation. But for a retailer who may want to now go out and go to the person who tweeted this and says, flat tire, on my way to work, glad these guys are working today also, whatever. But it could be that a retailer with a tire center looks at that and says, now I want to tweet back to this person and say, come in and get a new set of tires and we'll give you a $50 gift card to shop in our store while you wait. Fairly interesting business proposition, and you can actually go in, with our solution, you can go right in and actually click this person, see who they are, and then, it's on the one I click, it's not going to work, but you can go in and actually tweet back to that person. You guys have any questions? Does this seem compelling and interesting?
Some risky clicks.
Every once in a while, right?
Well, that post is from 2014, so
yeah.
yeah.
You'd want to have
he might not tweet anymore.
Right. Well, you want to have he may have deleted his profile. It might be a good thing, right? Anyway, yeah. So we don't have the full fire hose, and we're just picking out tweets that have geospatial location and information like that. But if you were, in the retail world, or looking at options of how do you better interact with your customers, how do you better interact with your brand.
So you can get a live feed from Twitter
telling you current tweets that are going on?
You can get a live, I mean, you can get a live Twitter feed, right? They have a fire hose that allows you to see everything. Kinetica doesn't pay for it, but we have kind of the smaller version. So we do have live tweets coming in, and we do update, but this is kind of a data dump that we took a while ago. So
A customer that wanted to invest in that could
sure,
invest in
a
that.
lot of larger companies with bigger budgets than we have those capabilities.
So how does this happen in like real time, right? Like when you get this data stream, do you save something in there? Like
It's a columnar data store. It is brute force. So we're actually using the GPU, and we use three things, right? The three components. We're storing everything in memory so you have very fast access to it. We use CPUs for what CPUs are good for, which is sequential tasks. And we use GPUs for that brute force data analytics, right? To scan a billion or billions of rows in milliseconds. And so you have 3,500 cores on a P100. So in a box you can have 4 of them, and then beyond that, you might have a much larger footprint. So we're seeing people put 4, 10. We have the U.S. Postal Service has a 4-way active. I think they have 4 servers in each cluster, and so it's 40 terabytes of data that they're running in their actual footprint, and they're tracking. I think it was 225,000 rolling assets. So the people delivering your mail on a daily basis, as they're going around, they have a GPS tracker, and that's sending out a breadcrumb every 15 to 20 seconds, and we're ingesting that data, and then we're giving them the ability to, in real time, visualize that, and then using simple Java code, they do event processing, so that they can look at route management, they can overlay traffic data, they can overlay weather data, they can do all these really interesting things. And they've said that they saved, in the first year alone, over 7 million gallons of gas. Pretty significant, right? Because that has a trickle-down effect as well. It's less wear and tear on the actual cars, less overtime, more efficiency by the drivers. They get to do change management, make sure that people are actually doing the things that they're supposed to do and being places that they're supposed to be. There was kind of a joke that one of the things when they first implemented this system they actually figured out is before this they were actually had these scans that they would go around to mailboxes and they would scale in a mailbox, and they figured out that some of the employees were actually taking pictures on their smartphone and scanning the smartphone picture if they weren't on time. So they've basically been able to get a better handle over things that are going on in their organization, and now they're looking at tracking every individual piece of mail from pickup to delivery, so that now if you have something that you're expecting from the Postal Service, they can actually send you a text or a notification that says you should expect this package within this window, so that you can be home. It's not like wait all day and hope that package shows up, and it's the 15 minutes when you ran out to grab a sandwich because you were starving that it showed up, and you end up with a Post-it note on your door that says we'll be here tomorrow. Because we've all had that happen. Me a lot. But, so does that make sense and help? We're seeing this across logistics. The retail environments are using this, oil and gas, working with some pharmaceutical and bio companies as well. Telecommunications, this is a big hotspot. Financial services, for insurance, for example. Insurance companies want to know where they have exposure, and as they look at events that are happening. So we just had this hurricane that almost hit Florida and Georgia, and I think kind of landed in South Carolina, and North Carolina, but insurance company might want to know, what is my exposure to this particular event, and how many people do I have that have insurance policies that are within some 50 miles of the coast or wherever they think this is going to hit. Well, we saw that hurricane started to come in and was going to hit like Cape Canaveral and Satellite Beach area, and then it veered back out east into the ocean, and then they were saying, oh, it's going to hit in Jacksonville, and just kind of went up the coast, right? So what the problem for a lot of insurance companies is to run all this analytics behind this, overlay this on a map, might take them a day. And when they need to readjust the information basically every 15 minutes, because there's a new point to which this is going to hit, right? So there's some pretty interesting opportunities, I think, when people start to be able to see this on a map, right? How can you change your business with having access to this data immediately and giving people visualization? And it doesn't have to be just a map. It can be graphs and charts and all the other neat stuff that we can do with the technologies that are out there. So I'm in between you guys and either going home or grabbing a beer. I know that Wes would love to take you guys out to Don Julio's. Don Julio's, is that right? Which is right down the street. Somewhere?
Yep.
So I appreciate your time. If you have any questions, let me know. Thank you very much for the opportunity.